Hello students. So today we will start with the engineering geology lab, that is 18CVL47, and we will start with the dip and strike problems. So what is dip and strike? We'll understand first. So the line on the ground or the trend of the rocks, that is called as the strike. So that strike in geology is the direction of the line which is formed by the intersection of the bed or the other planar features and a horizontal plane. So where the bed and the horizontal plane intersect, that line is called as the strike line. Then the next concept is your dip. So dip is the angle or acute angle that a rock surface makes with the horizontal plane. Means the angle made by the bedding plane with the horizontal surface is called as the dip of the bed. So it is further divided into true dip and apparent dip. So let us understand what is true dip and apparent dip. So this dip, that is, it is 90° to the strike or perpendicular to the strike, that is called as the true dip, which is always 90° with the strike line. That line or that direction which is 90° to the strike is called as the true dip direction. Then other than true dip, all the directions, they are called as the apparent dip directions. So it may be either more than 90 or less than 90. So other than 90, all the directions other than 90°, they are called as the apparent dip direction. So this concept is very important to solve the dip and strike problems. So dip and strike. So true dip is always 90°. You have to remember 90° to the strike line. So all these are apparent dips, and the 90° to the strike is called as the true dip direction. Then the relation between the true dip and strike line is they are always perpendicular to each other. This is very important. That is, relation between the true dip and the strike line is they are perpendicular to each other. That means it is 90°. True dip is 90° to the strike line. Now we will begin with the problems. So there are four different sets of problem. So we will see one by one. So just see what is given in the set 1. So in set 1, the amount and direction of the true dip is given. We need to determine the amount of apparent dip in the given direction. Means here what all things are given? The amount and direction of true dip is given, as well as the apparent dip direction is given. We need to find out the amount of apparent dip in the given direction. So that is the aim of the first set. So there are three examples in the set 1. So the problems are given as 1.1, means from set 1, first problem, from set 1, second problem, and third problem. So we'll discuss one example here. That is the first problem. A grit bed dips at the rate of 1:6.5 in the direction due north 10° east. So here what is given? The direction and amount of true dip is given. That is, the direction is north 10° east. Along that direction, the amount is 1:6.5. Then what is asked? What will be the amount of apparent dip in north 60° east direction? And also we need to find out the strike direction. So here along north 60° east, what is the amount we have to find out. So the problem is very easy. So we'll see first what is given data. Apparent dip direction is given, that is north 60° east. Along that direction we are going to find what is the amount of apparent dip. Then that is apparent dip amount we are going to find out. Then the true dip direction and true dip amount is also given. Then we need to find the strike direction. So first we will begin with the problem. So how to solve these problems is, first with exact measurements we have to draw the north, south, east, west line meeting at point O. Okay, are you getting? You have to draw exactly perpendicular two lines with the help of set square. Okay, that is exactly 90°. The two lines we have to draw, that is north, south and east, west direction. That line is meeting at point O, that is the origin or center of that line. Okay, so then first we will mark the given angle. So there is a grit bed which is dipping at the rate of 1:6.5 in north 10° east. Means how to measure the angle is, from north it is 10 degrees east. Means from north line we are going to measure. So keep your protractor on the point O on the north direction. Then from north measure hardly 10 degrees towards east. So we will solve the problem. Okay, so this step we have done, that is the drawing of north, south, east, west line meeting at point O. Then see here we have to draw north 10° east direction, that is nothing but the true dip direction. Then what is the amount given on this direction is 1:6.5. Means along that line from point O we need to measure 6.5 centimeter distance. So that is your true dip amount. Okay, so what we did, first we have drawn the north, south, east, west line meeting at point O. Then we have marked the true dip direction, that is north 10° east, and along that line we have marked 6.5 centimeter distance. Now this is the true dip. Now we know the relation of true dip and strike. How will you find out the strike direction if you know the true dip? So the relation here we are going to use is, true dip is always perpendicular to the strike. So what we will do, how to draw the strike line? We have to draw a perpendicular line which is passing from the distance 6.5 what we have measured. Give that point as A, you name it as A. So from point A we need to draw a perpendicular line to OA. So this is how we have to draw the perpendicular line to OA. Okay. Now what is next given? So this is the true dip and strike. Then next what is given? North 60° east direction is given. So you can draw this line parallel which is passing from O, that is nothing but the strike line, and you can measure the angle between the north and the strike and south and the strike. So I'll tell you how to measure that. Before that we will mark what is that, the apparent dip direction, that is north 60° east. So measuring angle is very important. Always we need to remember that we are going to mark the angle from north, taking north as 0, towards east we are going to count. So from north as 0, 10, 20 and up to 60 degrees we are going to mark. That is the given apparent dip direction. Now this line of north 60 degree east, where it meets the strike line, that point is the required answer, that you can name it as B. Okay, so how we got the point B? We have drawn the apparent dip direction north 60 degree east, and where it meets the strike line, that is the amount in the given direction, that is north 60 degree east. So if you measure the distance OB, okay, so that is the required apparent dip amount. Okay, so this is the first problem we have solved. Then the last strike direction, how to measure? See here, the same strike line, we have to draw a parallel line. We have to transfer this line, parallel line we have to draw, passing from the origin O. Okay, and measure the angle of that strike line from north. What is the angle towards west? And from south, what is the angle towards east? So always we have to remember, any angle which is in the first and fourth quadrant, we are going to measure from north, and angle between any angle in second and third quadrant, we are going to measure at uh, the down. Okay, down angle we are going to measure taking south as 0, and top whatever angle we are getting, that we are going to measure as north as 0. Okay, so from south, what is this direction? From north, what is the direction we will measure? And that is the strike direction. So here we have used 1:1 scale, that is one unit is 1 centimeter. So this is how we are going to solve all the problems. Okay, so here we have to write down the results also. So what results we got? The apparent dip amount, that is you have to measure the distance OB, and we have to write it as 1:10. And strike direction, that is the angle of the strike line, that we are going to measure and write it as north 77 degrees west and south 77 degree east. So both the angles we need to write to show the strike direction. So this is the first problem. Then 1.2 you can solve on your own. Now I'll solve 1.3. Okay, so 1.3, what is given? Just see, there is a gold vein which has a true dip of 1:4. There is a gold ore body, and that is having a true dip of 1:4 in north 60 degree west direction, and we need to find the apparent dip amount due north 80 degree west and due west, and also we need to find the strike direction. So what is given? Apparent dip direction is given, that is due north 80 degree west and due west. Then along these three directions we are going to find out the apparent dip amount, and true dip direction and amount is given, that is north 60 degree west and amount is 1:4. So we will see again how to solve the similar way. First draw a north south east west line meeting at point O. Okay, exactly perpendicular we need to draw it. Then first measure the true dip direction, that is north 60 degree west. So from north as 0 towards west, we are going to measure the 60 degree towards west. From north as 0, 10, 20 up to 60 towards west. Don't go wrong in measuring angles. So measure the angles properly. So north 60 degree west is the true dip direction. Now what is the amount? 1:4. So we will take the distance OA, that is 4 centimeter. Okay, so that is the 4 centimeter. We will give it name, we'll name that point as A. How we got? The true dip amount, that is along north 60° west, the amount is 1:4. So here it is 4 centimeter I have marked. Okay, then what is the next step? We need to draw a strike line which is perpendicular to OA. Okay, because OA is our true dip. So true dip is always 90° to the strike. So we have to draw a perpendicular line to OA from point A. So this is the perpendicular line to OA, that is 90°. Okay. Now we will transfer that line. We'll draw one more line here which is parallel to that strike line, that is the strike line. Okay, then what is the required answer? We need to find the apparent dip amount in the given direction. So what are the given direction? Due north, what is the amount? Then we are going to mark north 80° west. So remember, from north, taking north as 0, we have to measure towards west 80° and draw a line. Then due west, what is the amount we are going to find out? So this is how we are going to proceed further. So this is the apparent dip direction, that is north 80° west. Now what is the required answer? Where the strike line is meeting the point B, point C and point D. Okay, that is due north, north 80° west and due west. So this is the required answer. We are going to measure the distance OB, OC and OD to get the apparent dip amount. So this is the first set, how to solve the dip and strike problems. Okay, then the final answer what you have to write is the strike direction you have to measure. So strike direction is the angle between north south line, north south east west line and the strike line. So here the strike line which we have drawn is making angle, okay, that is north 30° east and south 30° west. Opposite angles are equal, so you can write the same angle, that is from north it is 30° towards east and from south it is 30° west. So this is the way we have to write the answer for this, and scale also. So this is the set 1. So here I have given your answers also. You can try problem 2 as a homework. So all these problems we are going to solve in the journal. Then we'll move on to set 2, that is the determination of true dip from apparent dip. So in the previous set the true dip was given and we have found out the apparent dip amount. But in set 2 we are going to find true dip from the apparent dip. Okay. So first problem, that is problem 2.1, 2.2, 2.3. There are 3 problems again. So here we will solve the first problem, that is problem 2.1. So there is a coal seam, that is a coal body which has apparent dip of 1:7 due north 12° east. Then there is a similar outcrop which reads the dip of 1:5 due north 35° west. And what is asked? To find the amount and direction of true dip. and also the strike direction we are going to find. So here the two apparent dip directions and amounts are given, and with the help of that we are going to find the true dip. Okay, true dip direction, true dip amount and strike direction we are going to find. So we will solve this problem as usual. We will draw first north south east west line meeting at point O, exactly perpendicular to each other we need to draw. Okay, then we'll mark the first angle or first apparent dip direction, that is north 12 degrees east. Okay, and north 35 degree west. Okay, so both the angles we are going to mark. Okay, so here north 12 degree east and north 35 degree west. Then we will mark the amount on that. So on north 12 degree east, what is the amount? 1:7. So we are going to mark it as 1:7 and you can name it as A or B. Then along north 35 degree west, what is the amount? 1:5. That is given in the problem. So we got the 2 points A and B. Then what is the next step? We have to join the point AB. We are going to draw a line joining the point AB. Okay. Now this is the apparent dip. From apparent dip we got the strike line. So the line which we have got, that is the strike line. Similar way we are going to pass it from the center. That is how we are going to draw parallel line from, that is AB, passing from O. Okay. Then the next step is we are going to find the true dip. So what is the relation of true dip and strike? That is, the true dip is always perpendicular to the strike. So we know the strike line now. Now we are going to find what is the true dip. So how we are going to do it? We need to draw a perpendicular line to the strike. Okay, and it should pass from center O. So this is the strike line and this is the true dip, which is exactly 90 degree to the strike line passing from O. That is the origin or center. Okay, so this line that we have drawn, that is perpendicular to the strike passing from O. So with the help of set square you can draw the perpendicular line to the strike, or you can even use the scale. If you coincide the scale line and strike line and just move it where it passes from O, you will get the true dip or perpendicular direction. Okay, perpendicular line. So this is the required answer. So that is what will name it as C. So the distance OC is nothing but the true dip amount, and the direction of that line, how we'll measure? It is from north towards west. So north, this angle is called as the true dip direction and the distance is called as true dip amount, that is the distance OC. Okay. Then also measure the strike direction. So how will measure? Angle from north towards east, from south towards west. So that is the angle of strike direction. So here we'll write the results. First, true dip amount, that is amount is 1:5 and direction. So there it is a mistake. There it should be true dip direction, that is the angle OC. Okay, so angle of the line OC from north, it is 34 degree towards west. So this is the set 2 first problem. So it is very easy. So how we did it? Just a revision. First, two directions are given and two amounts are given, that is apparent depth. So we will mark both the angles and both the amounts on the respective lines, and then we will join the point A and B. So that is the strike line. Then we will transfer we will draw parallel line from O, that is the strike line again. Then we will find out true depth perpendicular to the strike passing from origin O. So that is the required answer. Angle and that is the direction and amount of that line is the required answer. So here similar way we are going to solve all the three problems. That is how we are going to solve the set 2. Answers are given. So plus or minus 1 degree or 1 centimeter distance is valid. So you can try all the remaining two examples. The two directions are given and two angles are given. So we are just going to join that and draw a perpendicular to the strike line, that is AB, passing from center. So that is the required answer. So remaining two sets we will solve in the next lab. Thank you. Hello students. So today we will start with set 3 and 4, that is from dip and strike problems. So what is dip and strike we have discussed. Dip is the angle of inclination of the bed with respect to the horizontal plane, and strike is the trend of the rocks or the direction of the line which is formed by intersection of bedding plane and horizontal plane, that is called as the strike. Okay, now we will see the third set. Here in the third set, what is given? We have to determine the apparent dip direction when the true dip direction, the amount and also the apparent dip amount is given. So it is similar to set 1, okay, wherein the apparent dip direction was given and true dip direction we have to find out, that is the amount, and also true dip direction and amount we are going to find out when the apparent dip amount is also given. So here apparent dip amount is given, true dip is given, that is amount and direction of true dip is given, and we are going to determine the apparent dip direction. So we will here also there are three problems, problem 3.1, 2 and 3. So we will see the first problem. A sedimentary strata has a true dip of 1:6.5 due north 20° west. So here the true dip amount and direction is given. Then what is asked? What will be the direction of apparent dip? In what direction will be the apparent dip direction when the amount is 1:13, and also we are going to find the strike direction. So here what is asked? The true dip direction and amount is given. We have to find out the apparent dip direction in and where the amount is 1:13. So when the amount is 1:13, what is the direction of apparent dip? This is the required answer. So given data, we are going to find the apparent dip direction. Then given is apparent dip amount is given, that is 1:13. When the amount is 1:13, what is the direction? That is asked. So and true dip direction and amount is given, and also we need to find the strike direction. Okay. Then so these are the given things. Set 3, problem 3.1. So here as usual we will draw one north south east west line exactly perpendicular to each other meeting at point O. Okay. So here we will use the scale, that is 1 unit is 2 centimeter. So we are going to reduce the scale to half because the direction is the amount given here is 1 is to 13. So 13 is too big to draw on the paper. So what we will do? We will reduce the scale to half. So if when you reduce the scale to half, 13 becomes half of 13 is 6.5 and half of 6.5 that also we are going to reduce. Okay, that is 3.25. So we will solve the problem. So first what we will mark, the true dip direction and amount is given, that is north 20° west. So this is the from north towards west 20°. Okay, for 0, 10, 20, that is the from north 20° west. Then what is the amount given on that line? 1 is to 6.5. So at 6.5 centimeter, that is at, we are going to reduce the scale. So here what distance you will measure? 1 is to half of 6.5, that is 3.25. So we will measure the distance exactly 3.25 and this is the given true dip direction and true dip amount. So how to get the strike line from this? Like what we did in first set, we are going to draw a perpendicular line from point A, okay, that is perpendicular to OA line. So this is the strike line what we have drawn similar to set 1. Okay, so this is the strike line which is drawn from point A, okay, perpendicular to OA and that is true dip. Okay, we have drawn a line with the help of a set square. Then what is the next step? We are going to draw a parallel line to this passing from center just to make it easy to measure the strike direction. So here this is the strike line. Okay, then how to draw the apparent dip uh, direct amount, that is given 1 is to 13. So half of 13 is 6.5. So what you have to do, you have to use the rounder, okay, and you have to measure the distance 6.5, that is 13, means we while drawing we will use it as 6.5. So this distance you have to measure on a rounder and from keeping the rounder at point O, okay, remember you have to keep the rounder at point O, okay, that is origin. From point O we will cut the two arcs on the strike line, okay, where it cuts the strike line, that is the two arcs we are going to draw of 13 centimeter, that is 6.5, because the scale we have taken is 2 centimeter. So 1 unit is 2 centimeter, so we are reducing it. So 13, half of 13 is 6.5. So with the help of protractor, we are going to draw the two arcs and name those two arcs where it joins the strike line. On the strike line we are going to draw the two arcs. We are going to cut the strike line with the two arcs of 6.5 centimeters. So that is, we will name the point as B and C where it cuts the strike line. Then the next step is to join OB and OC. So that is the required answer. So what is asked? obviously it will be 6.5, not 7.5, it is 6.5. Okay, so there is little correction. You have to measure it as 6.5, not 7.5. Okay, so here 6.5 is the given, that is the given distance, that is nothing but the 13, half of 13 is 6.5. Then what is asked? The direction of these two lines, what we have drawn with the help of cutting arcs. So the direction of these two lines is what? OB and OC. Okay, the direction from north, what is the direction? Towards west. And from north, what is the direction of this OC line? Towards east. So this is the required answer. So we will measure the angle from north. Okay, what is the angle from north? What is the angle towards west? Okay, so these two are the required angles, that is measure this angle to apparent dip directions. So in the given amount, that is 1:13, these are the two directions we have got, and also we are going to measure the strike direction. So the direction of the strike, how we'll measure? Angle from north to the strike and angle from south to the strike. Okay, so this angle is called as the strike direction, that is north 69 east and south 69 west. Okay, and what is the apparent dip direction? So this angle from north, what is the angle towards east? That is again OB and OC. So this OB is how much? OB is north 81 degree west and this is north 39 degree east. So this is again a small mistake here. Okay, the OB is this 81. Here it should be C and this should be B. Okay, so you make the correction, you write the proper angle, whatever name you are giving, exactly you may write the angle of that line. Okay, so this is how we are going to solve the set 3. So these are the answers for set 3. So 3.1, 3.2 and 3.3. So in problem 3.3, the two directions are given, that is two amounts are given. So total we have got here 4 answers. So one so suppose for 9 centimeter one amount is given, for that we have to cut the 2 arcs, and one more amount is given, for that we are going to cut the 2 arcs. So these are the answers for 4 answers we have got in set problem 3.3. So that we have to take care. Okay, next we will solve the set 4. So set 4, what is given is the strike direction is given and apparent dip is given. We have to find the amount and direction of true dip. So in all the rest problems, all the sets, the strike direction was not given. We have found out the strike direction, but here in this set the strike direction is given and we are going to find the amount and direction of true dip from the strike. Okay, it is something reverse of all these. So here you can see there are two problems. First problem I'll show you. There is a soft shale bed in a hillside cutting and it is striking north 40 degree west with an apparent dip of 1:5.5 along south 20 degree west, and what we need to find is the amount and direction of true depth. So here strike direction is given. Along this strike direction, what is the true depth we are going to find? So the given data, the amount, the apparent depth direction and amount is given. From this we are going to find what is true depth and what is true depth direction and true depth amount. And also we need to find the also the strike direction is given. So here we will see how to solve this. Okay, so first we will draw north south east west line meeting at point O. Then we'll take the scale as 1:1. Okay, so because 5.5 is the maximum distance, so we will take the scale as it is. 1 unit is 1 centimeter. So we will solve first. What is given? The apparent depth direction is given, that is south 20° west, and amount is given 1:5.5, plus the strike direction is given, that is north 40° west. So first I'll draw north 40° west, that is nothing but the strike line, that is north 40° west. You can extend the line. Then we will mark the apparent depth direction, that is south 20° west. And what is the amount given on that? It is 1:5.5. So when you measure the angle, you have to be careful. From south towards west 20°. So here 10, 20, like that you have to measure the angle. So along this line, that is south 20° west, what is the amount? 1:5.5. Okay, so the direction is south 20 west, and amount here I have marked the point as A. Okay, that is 5.5. Now what we need to find? The strike is given and apparent is given. We need to find the true depth. Okay, so to find that, we need to draw a perpendicular to this strike line. So how to draw that? Now we will transfer this line, or we will draw a parallel line, that is strike line, from point A. Okay, are you getting? Earlier here the line we used to get in all the problems, and then we used to transfer it to O. Now here we have got the line at O, that line we are going to transfer at point A. Okay, reverse. So here you have to draw a parallel line from point A. This is very important. You have to remember how to draw the strike line. So here transfer this strike line from point A. You draw a parallel line from point A. Then can you draw now what is true depth? It is perpendicular to strike passing from point O. So you can use the set square to solve this. Okay, or you can keep a scale on this line, that is like this, and coincide the scale line and this line. So where and you just move the scale where it passes from center. So here you will get the line, that is the exact 90°. That distance is B. So OB distance is the true depth amount, and this angle between OB line and south line, that is this angle, is the required true depth direction. So if you measure this distance OB, that is the true depth amount, and this angle is the true depth direction. Results, we will write it as south 50° west, and this distance OB is the true depth amount, that is 1:4.8. Okay, then similar way you have to solve the problem 4.2, that is These are the answers given. So first you have to draw similar way you are going to solve the problem 2. Okay, first draw north south east west line meeting at point O, mark the given strike line and the apparent dip. Then you just transfer the strike line from that point A. Okay, parallel line you have to draw from point A. Okay, then to this line we have to draw a perpendicular passing from center. So that will give you the required true dip direction and amount. Thank you. So this completes your dip and strike problems. So in the next class we will see the borehole problems.